let's get started. Okay, so I think it's now me for the rest of the semester. So we had for whatever reason, Esther and I swapped one lecture last week. Now, this week, now I'm back. Okay, so what I want to talk about today is land markets, and including the paper you guys read for today. And broadly speaking, we're going to cover, I think, two broad themes in land markets. So one is sort of why the allocation of land may matter. So that's moral hazard and sharecropping issues in particular, related to the paper you read today. But I'll start with some basic theory on this stuff. And then the other question is sort of how do we think about property rights? And why do secure rights over property matter? How do we think about land titling and things like that, and the implications of those for investment decisions? So mostly today is going to be like moral hazard and sharecropping. And I guess today's Wednesday, so Monday will be primarily on investment decisions and stuff like that. Okay. Okay. So stepping way back, right? Sharecropping is kind of a very old subject. It's been around for forever, essentially, or for a very long time, and that's when sort of laborers pay owners a share of the output. Okay. So sharecropping is a ubiquitous subject and has been thought about for a very long time. Going back like even to economists like Smith and Marshall were sort of talking about this issue, and not only just talking about it, but recognizing that there may be an inefficiency from sharecropping, right? And the inefficiency is you don't get the full returns to your labor, right? Because some share of it is going to the landlord, so that could lead you to sort of not work as hard as you would otherwise, right? That's the basic issue, okay? So here's just like a super duper simple model to sort of make this very clear. So imagine that there's some output. The output is f of I, that's some input. Tenant pays some cost C, could be their own labor, whatever. Owner receives a share of alpha of the output. So what's going to happen? The tenant is going to solve, some problem. They're going to, they get taxed essentially 1 minus alpha on the output. They pay the full costs. The first order condition of that is just that the marginal product is equal to the marginal cost modulo the tax rate, right? So if they're being taxed, that's going to be the marginal product is going to be greater than C, and therefore if F is concave, they're going to put less input than they would otherwise, right? That's like super duper basic like tax. If you tax things, people do less of them, right? Okay, so one thing that's worth noting actually that's very important is this is the key thing that's driving this distortion is that this is a tax on output, not a tax on profits, right? So if I wrote this exact same, if I changed this so that instead of having a tax on the output here, I taxed your profits, which is your f of I minus CL, then in that case it wouldn't matter, right? You can just check that sort of the solution here is the same as if there was no didn't have to share the output here. Okay, and that's this general fact is that profit taxes are non-distortionary, and that's actually related to broader issues of like why are corporate income taxes, for example, taxes on profits, not taxes on revenues. It has to do with like these kinds of ideas, right? So of course the problem is that what we can observe is your output. Right? It's not. Although as you talked about, as you saw in the paper, even observing the output is hard. But it's at least more plausible that you can observe the output rather than observe your profits. Especially if we think of like a agricultural, self-employed farmer or something where a lot of their inputs are their own labor or things like that. Like that's very difficult to actually observe and measure. So the distortion comes from the fact that we're taxing revenue, not taxing profits. Okay? Clear? All right. So the solution, and actually I think at least one of you sort of talked about this in your reading response, is the solution to this problem is a rental contract, right? So faced with this, what should they do? Rather than have this distortionary contract, well, what should happen is the tenant should rent the land from the landlord for a fixed rent R and keep all the output. Okay, and so that contract would look like this. Right? It would look, the tenant would maximize I minus F, maximize over the inputs, F of I minus CL minus R, the fact that this R is a lump sum here, so it doesn't affect kind of the decisions. So that gets us the first best. Okay? So in some sense, that's the benchmark solution to all these problems, is we should just, the tenant should rent the land for a fixed fee. So why does that not happen? Okay. So there's a couple of reasons why this doesn't happen, and that's kind of what I'm going to talk about for the next, half an hour or so, right? So one comes from Stiglitz, and the idea is that there's a trade-off between incentives and risk sharing. Okay? So the problem with this contract, right, is that if we imagine that the output is risky, the tenant is bearing all the risk, right? And the landlord is is getting a fixed fee regardless. You might imagine that the tenant is, typically like a poor farmer, and the landlord might be a kind of rich landlord. In that case, you might imagine that the rich landlord might be less risk averse than the poor tenant. But even if actually they're equally risk averse, the optimal thing is not for one of them to bear all the risk and the other to be totally insured. The optimal thing is to share some of share the risk between them. Okay, and once you share the risk between them, then you end up in some kinds of contracts where you end up that look more like sharecropping contracts. Okay, and so that's kind of the basic idea of this Stiglitz model, which was actually one of the kind of original moral hazard models, actually developed with kind of sharecropping as kind of an example, is to say, well, we'd like to, we end up in kind of these inefficient, these contracts that are productively inefficient because we want to do some risk sharing. Okay, so let me go through a little bit of that. Go through that a little bit of that. Any questions? No? Clear? Okay. So that's basically what I said. So just to be clear, the idea of this is that farming is going to be risky, so we're going to put some uncertainty on this. Risk-averse agents want to be insured against this risk, but the problem is if this effort choice is uncontractable, that leads to inefficiencies. Okay. So here's a very simple, like the simplest possible kind of simplest version of this model. So let's consider a two-state version, high and low output. Okay. There's effort, which is denoted by E. The farmer chooses some effort, E, but the landlord doesn't see E, they only see output. Okay, so we can't write, and the key point is we can't therefore write contracts over the level of effort E. Effort's going to be costly to the tenant with some cost 1/2 C squared, and the output is going to be stochastic with the effort determining the probability of the high state. So with probability E, the output is high. With probability 1 minus E, the output is going to be 0. Okay? And the way we sort of think about these models is the farmer and the landlord are going to write a contract which is going to specify a payment to the farmer from the landlord. I think that's the way I did it. Doesn't matter which way you write the payment. Which is going to be a payment H, little h, if the output is big H, and a payment little l if the output is 0. Okay, so we're going to be interested in sort of what those little h's and little l's are. Okay, so setup clear? So just to be clear, the key thing in this model is that the effort choice is going to drive the probability of the high state or the low state. Okay. So what's the first best? Yeah, Davey.
Just like here, the output is observable and contractible.
Output is observable. What, sorry?
And contractible.
Yes, exactly. We're going to write, the output is observable. We're going to write contracts on output, but we can't write contracts on effort. Okay? So basically, the way this model is going to work is the landlord is going to set up the contract. Here's the H, here's the L, which are functions of what the realized output is, and then the tenant gets to sort of observe H and L and make their decisions about how much effort to put in. And then the landlord gets to set, and the landlord in turn chooses little h and little l, knowing how the tenant will respond and make their contracts decisions. Okay? It's a standard moral hazard setup, but not everyone has seen these before, so I want to go through this. Okay, clear? All So what's the first best? Well, the first best, right, would be that. So remember in the low state we get 0 just by normalization. So that's just going to make the math easier. So what's the first best? Well, the sort of social optimum, right, is to choose a level of effort such that the expected return, which is the probability of getting the high return times the value of the high return, you balance that against the cost of effort. Okay, so we just take the derivative here, and E is equal to capital H over C. That's the optimal first best level of effort. Okay? So that's the benchmark, right? The question is, are we going to get that level of effort or not? Okay? So what's going to happen? So the question is, can the landlord, by the way, if I'm going too fast, like you should, slow me down. The problem with teaching on slides is, teaching models on slides is you tend to go faster than people can write. So if I'm going too fast, just slow me down. So can the landlord implement this first best contract? Like what's going to actually happen? Okay, so how do we solve this? So the problem for the landlord is written as the following. So the landlord is going to has two choices. What is little h and what is little l, right? And what does the landlord care about? Well, with probability E, which will be determined endogenously, the output is big H, and the landlord has to make a payment little h. Okay, so that's the landlord's return in the high state. With probability 1 minus E, we're in the low state, and the landlord has to pay L and gets no output. Okay, so that's the landlord's objective function. This is, by the way, this is all going to be risk neutral, as you'll see in a second. But we can introduce risk aversion later. But so that's the landlord's problem. And it has two constraints, the incentive compatibility constraint and the individual rationality constraint. The incentive compatibility constraint says the landlord is going to solve this problem knowing that the tenant will in turn take the contract as fixed and choose her level of effort accordingly. Okay? So the tenant here is going to solve for a level so the level of effort E is going to be chosen by the tenant to solve the tenant's own objective function, which is, well, with probability E, I get payment little h. With probability 1 minus E, I get payment little l, and I have to pay my cost of effort. Okay? And there's a third constraint, which is the individual rationality constraint. And the way to think about the individual rationality constraint is that the tenant has some outside option W bar, and the tenant's net utility has to be at least equal to W bar, W lower bar. Okay, and that's to say the tenant could like not take this contract and could walk away and just kind of get a job as a day laborer at some rate W. So the net utility from the tenant, so that's this term here evaluated at the chosen E has to be at least as high as her outside option. Okay, so this is the problem. Clear? Okay. So and if those of you who have taken contract theory already, this should be like very familiar, right? Okay. So how do we solve this problem? Well, we begin by taking the farmer's solution, taking the contract, the IC is given. Okay. So we basically say, let's first solve the farmer's problem. Given a little h and little l, what is the farmer going to do? And then we'll plug that back in to the landlord's problem, right? So what's the farmer's decision? Well, the farmer is going to maximize this objective function over here, right? Remember, she gets payment little h with probability E, payment little l with probability 1 minus E. She pays the cost of effort. So her effort decision, as you can see, so right, we can just take the derivative of this to E. She's going to she's going to get h minus the sort of what additional E does is it increases the probability she gets h minus l, right? The difference in her right, the difference of the high state is the difference in her payment in the high state minus the difference in the payment in the low state, and just is equal to the marginal cost of effort. Okay, so her choice is going to be E star is going to be equal to h minus little l over C. Okay, so what you can immediately see here is this is a model where if there's no difference between the payment in the high state and the low state, if she's fully insured, she puts in no effort. Okay, so there's going to have to be some. This is a model where if there's full insurance, there's going to be no work. So they have to provide some incentives in order to get her to put in some effort, right? Otherwise, right? Why would you do anything, right? Because there's some cost of effort. Okay, clear? All right. So now, the landlord. So we can also see immediately, by the way, that to get the first best, right? Remember the first best effort. First best effort was we'd like the landlord to. We'd like the tenant to put an effort equal to big H over C. So what does that mean? Well, the contract. Any contract that's going to get the tenant to put in the full amount of effort, that's going to imply, right, that little h minus little l is equal to big H, right? Which is another way of saying it is that the gap between what she gets in the high state and what she gets in the low state has to be equal to the social, in some sense, the social return of being in the high state versus the low state. Okay, that's the only way to get her to put in full effort. Okay, so you just see that by saying, look, if we want this to equal to big H over C, we have to make the difference between little h and little l equal to big H. Okay, so that is a rental. What is that? That's a rental contract, right? We've just derived a rental contract. Why is that a rental contract? Because the tenant will make some fixed payment to the landlord. Like another way of viewing it, any contract where the difference between little h and little l is equal to big H is a contract where she makes some fixed payment to the landlord, or maybe it goes the other way, depending on what her incentive or her IR constraint is, but there's some fixed payment that goes one way or the other, and then she keeps all the output that is produced. Okay, so that's a rental contract. Okay, so we've just kind of derived the result that basically another way of saying it is in this model, the only way to get the first best effort is to have a rental contract. Okay. Right, which is basically what I just said on the slide. So why is that? We need the worker to face the socially optimal return to effort. So we need E stars. We need this, right? Her choice of effort to be equal to the socially optimal level. The only way to do that is to set H minus L equal to big H, which basically means she keeps all the return on the margin. Okay. Now, in this contract, now we've pinned down little h minus little l. But we haven't pinned down, but we can sort of slide the level of those things up and down, right? That's the rent, right? And so how do we choose the rent? Well, we choose the rent so that the farmer is going to obtain W lower bar in expectation. Okay, that's the IR constraint. Okay, so the farmer's utility, remember what was the farmer's utility? The farmer's utility was, so now in the first best contract, with probability E the high state happens, she gets H. The rent gets paid either way, right? No matter what, you pay the rent, and you have to put in the cost of effort. And we know, by the way, that the effort here is going to be equal to big H over C, so we can just sub in big H over C, right? So substituting in big H over C here, her utility is going to be h square over c minus a half h square over c, so we get a half an h square over, sorry, so we get a half an h square over c minus the rent. Okay, so that's her utility under this contract, her expected utility under this contract. And that has to be equal to the outside option, so we're going to set that equal to W lower bar, right? And so that's the rent. That determines the rent. So the rent is going to be the level where she's exactly indifferent ex ante. Okay, and that's a general feature of the way that you sort of solve a lot of these problems. Is you figure out you first kind of solve for what the IC constraint and sort of what is the difference between you sort of solve the problem to say what's the difference between the high state and the low state payoff, and then you slide the whole thing kind of up or down so that the agent is exactly indifferent to their outside option and their IR constraint. Okay, so that's the general way you solve these moral hazard problems. Okay, so that's the rent. That pins down the rent. Okay. Clear? So that's the final contract. Final contract now. So now we know both the little h and the little l. So little h, so our r here was h squared over 2c minus w bar. So we can substitute in. So we get the payment is like 1 minus the r, right? Because it goes the other way. So this is minus r, right? That happens in either state state of the world, and the difference is she gets to keep the output. So that's just another way of writing, like there's a rent equal to h squared over 2c minus w bar. That's the rent, and then she keeps the return big H. And that's just sort of the way of expressing it, kind of in this contract space. Okay. Is that all clear so far? All right. So this is a nice contract because the farmer is going to, the farmer gets no rents, right? It's nice from the perspective of the landlord, right? The landlord likes this contract. The farmer is getting no rents. She's getting exactly equal to her outside option in expectation. So the landlord is capturing all the surplus, and she puts in full effort. So that's like great. Landlord loves this contract. Problem is, there's two challenges with this contract. Okay. The first challenge with this contract is the farmer is bearing all of the risk. Okay. So the second, that's the first problem. Second problem is the farmer with positive probability is going to earn this L, and that may be negative, right? So she may get less than 0. So what happens if she has no money and can't pay, right? So then we have a second issue, which is what we can think about what are called limited liability contracts, where you're capped at 0 from below, right? You can't ever go below 0. If you have no money, you can't pay the rent, right? And so this one is kind of like a risk and insurance issue, and this is a limited liability issue. And both of these can give rise to what looks like sharecropping arrangements, but the implications of them are going to be a little bit different. Okay, so that's what I want to go through next, is to say, well, how do we think about each of those, and how could each of those different reasons lead us to a sharecropping arrangement? Questions? All clear? Yeah.
In practice, limited liability just means that I can't go. I can't force you to take out a different loan. I'm not sure to take out this time.
Yeah. So correct. So when might limited liability be a thing, or might not be a thing? So yes, right. So you can't. So you're right. It means we can't force you to go take out a loan to pay the rent, for example. Although even in kind of debt contracts, right? Like, why might that be? Well, you could just like leave, for example. It can be hard to. So that's basically the and we'll talk about those contracts, limited liability, also when we get to the credit lectures at the end of the semester, where a lot of these same issues are going to come up. But you could leave. You could it could be hard to enforce. Like, there's a variety of reasons. Or you might, right, so you might have access to credit. Yeah. Other questions? Okay, so let's explore both of these. So what happens when the farmer is risk averse? So now let's assume that the landlord is risk neutral, okay, but the farmer has some utility function which is concave over consumption in both states. Okay, and actually, you can do this with, as I said, with both parties being risk neutral. Actually, the math gets more complicated. Actually, all these moral hazard models, actually, the math gets can get a little unpleasant. Ed, you're nodding. I can see you. They're surprisingly not pretty models. I think there's nothing. I don't have a good reason why that is, but that's true. So okay. So and if anyone wants any proof of that, go back and read Stiglitz 74, and you'll see it's not pretty. Okay, I think it's just like carrying around, solving all these contracts with all these concave utility functions just gets a little difficult. Anyway, so now what happens? But the key result actually is very easy to see. So this is exactly the same as before. Now the farmer has, like this is concave, we're maximizing E times U of H and 1 minus E times U of L as opposed to just H and L directly. And so one thing to point out is if the landlord implemented the contract from before, the farmer's utility is going to be strictly less than W lower bar, right? And okay, because of the sort of I mean, this is actually not totally precise. Oh, sorry, this is precise actually. Then U of W lower bar, exactly right. That's precise. Okay, and why is that? That's just from concavity, right? That's just because so U of W lower bar, right, is the utility of the sort of expected return, and kind of what it means to be risk averse, or what concave utility functions give you, is that the utility from the expected utility is less than the utility of the certainty equivalent. Okay, that's just what we get from concavity. Okay, so that means that so what does that mean practically, right? It means practically if we took the contract from before, like that's the worker is now below her IR constraint. So we got to do something, okay? Otherwise she'll walk away. And what could we do? Well, we could lower the rent. We could raise kind of the fixed fee, or we could provide some insurance and reduce the gap between H minus L. Okay. And the question is, which should the landlord do? Should they like should they do it all on the fixed fee margin, or should they do some of it on the other margin? And one simple way to sort of see that they should do at least some of it, at least a little bit of it on reducing the H minus L gap is as follows, right? So it's basically just this argument here, which is starting from the first best level of effort, right? The efficiency loss from reducing H minus L just a little bit is second order, but the utility, because we maximized that, right? So the loss there is second order, but the utility gain for the agent is going to be first order. Okay, so that's a simple argument which says the solution to this problem can't have H minus L be equal to the full kind of equal to cap H, right? We're going to do at least a little bit of this sort of reduction on the dimension of sort of providing a little bit of insurance, because that's sort of second order in terms of the total kind of productivity loss, but first order gain in terms of the insurance value. Yeah, Aaron.
Is that true when the landlord is also risk averse? Or?
Yes, because another way of thinking about it is like the landlord is bearing. Let me think for 1 sec. Yes, it's true, but let me just double check. Yeah, I'm pretty sure it's true, because it's going to be. I think it's going to be a similar kind of argument that the landlord. I was trying to think of whether you need any other conditions. I don't think so, because I think that the landlord is going to be fully It's a similar argument. Going from fully insured to an epsilon bit of risk is going to be less costly than sort of reducing the risk a little bit. I'm pretty sure that's right. Yeah. Okay. So on the other hand, so that says, look, the optimal contract is not going to be the first best. It's going to have at least a little bit of a sharing feature. On the other hand, we also know that we can't fully insure the agent, because then the agent won't work. Okay? So this kind of argument says that the optimal contract is going to look something like a share contract, where there's, maybe with a fixed fee, but it's going to have some feature where the sort of the share of the output that the agent keeps is less than the full output. So some amount of the output is sort of shared with the landlord. And that even though that has a productivity loss associated with doing that. Okay? But it's not going to go all the way to the other dimension of full insurance either. Okay, so that's kind of that's in some sense this is the key insight. And this, I said, is the argument for sharecropping given by Stiglitz, which is that landlords and peasants actually prefer. So the Stiglitz argument is actually kind of like it's almost revolutionary in a sense. It's to say, look, like, you know, not revolutionary in the sense of like let's have the revolution, but like revolutionary, almost in the opposite sense, actually, to say, look, like you might have sort of thought that, like, you know, this landlord, the sharecropping thing was this total like exploitative thing, and like if only the tenants could kind of get out from under it, they would like be much happier, right? But actually, he says no. Actually, the sharecropping is like preferred by the tenants in some sense to the full rental contract because they're getting some insurance value. Okay, and otherwise, because like life is really risky. Right, and so it's a way of providing some combination of providing insurance and incentives. Yes.
You cap the rents in this model because you don't want the landlords to extract up the surplus or something like that. Does that change efficiency at all?
It doesn't change efficiency. Sorry. So what happens in this? Let me think for a sec. So you're saying what happens if you put in a restriction saying they have to give more rents?
Yeah.
Let me think for a sec. So if I increase the rents, will I don't know the answer off the top of my head. Okay. So like you're saying, if I increase the rents, will the landlord sort of like compensate somehow?
Yeah, I'm just trying to understand, like, I understand why.
So I think actually in this model, no. So I'm not totally sure, and the reason I'm not totally sure is that, in general, the way we solve these models is we figure out what the sort of the gap is, and then sort of slide up and down to hit the rent floor. And so that's essentially what is the impact of raising the outside wage, essentially. And the reason I'm not 100% sure is it also affects the risk aversion, and that's what's confusing. That's why I'm not giving you a quick answer, because in a concave model, if I move the sort of overall payment up, it makes me less risk averse, and so I'm not 100% sure actually. Does anyone else know the answer to that question? That would be a good problem set question, actually. I don't know. Sorry. That's a good question. Yeah, Kailash.
So is this meant to, like, you can't write this directly as like an outcome tax, right? Is it just?
What's that?
Like, as in you couldn't write this contract as like the output model that we saw, or is it exactly?
Yes, you could. Sure.
Okay.
I mean, well, so that model didn't have any uncertainty.
Okay.
Right. So. Okay, so what is different in this model versus that model? So that model had no uncertainty is the key thing. And the other thing which is important is that the effort choice here affects kind of the probability of is related to the uncertainty. So it is a bit of a different model in that sense. But conceptually, yes, you can think of this as a bit of the solution looks like an output tax.
That's just a percentage of output.
What's sorry?
It's just a percentage of output. That's it.
Well, I mean, this is sorry. So in the continuous case, so you can write. There obviously are continuous moral hazard models, right? In which are even more difficult to work with, but you can solve them. And if you take a contract theory class, you will solve them. And in those models, yes, I think it will look like you'll get some payment as a function of the output, and it'll all be continuous. It will look like an output tax. Whether it will be a linear output tax, I don't necessarily know that that's always true. Although Bengt Holmström has a well-known paper in contract theory that sort of shows under what circumstances linear incentives are optimal. So I think and I'm not remembering the details of these models off the top of my head, but my understanding is the general in the general answer, it will not necessarily be a linear incentive function. However, what Banks shows is that under some various perturbations where you can sort of do some gaming or other things like that, linear contracts often do emerge. That's sort of my summary of that. And you were nodding, yes, anyone else want to comment on that? Okay. All right. Other comments? So I think, I don't know if we still have an example in the problem set. We should make sure we don't, that's gone.
There's no problem set on this topic.
Okay, so if you would like to work through an example of this, I do think we have a previous problem set that we have put together on this problem that has an example of how to work through these moral hazard models. Yes, Davey.
Just we show here the agent's participation constraints still binds. Right?
Yeah.
There's no surplus on the agents.
Right. Yep. They're still going to sort of slide it down. It's still going to be the case that the IR constraint is still going to bind. There's going to be no surplus here. Yeah. Amit.
You see, like, I can speak. Anyways, you see these kind of contracts, like for instance, the tax contract, like you pay a fixed rent, and then you get everything. Let's say the first best is in the taxi business, we see the first best.
We see both. But yes, with Uber, you see a sharecropping contract. I mean, they don't call it sharecropping, but like you see a share contract, right? Where it looks, where Uber takes 30% of the, or whatever the percentage is of the thing, and they get a fixed some share.
Is there a reason why, say, like,
sorry, one other thing. But in the Uber contract, it's observable, and I think it may depend. I think I don't know the full economics of the taxi cab literature, but I think it probably depends on to what degree, certainly to what degree effort is observable, would affect kind of what these contracts look like. And Davey is nodding since Davey is sort of like actively sort of looking at exactly these issues of observability and sort of the endogenous contract choice in Côte d'Ivoire at the moment. And we just lost my computer. Sorry, go ahead while I get my computer back. Yeah.
Can you answer my question?
What's that?
I was going to ask, what kind of industries would we expect to see, say, ex ante like the first best kind of contract?
So you would see. So for example, if you had no observability of output, then you would see a rental contract, right? So this contract requires the principal to be able to condition the payment on the output, for example. Or you also might think that taxi cab drivers may not be that risk averse, right? So if the uncertainty is kind of day by day, right? This is over a whole season, right? It's kind of one giant realization. You're really risk averse about that. Some days it rains, some days it doesn't rain. Like, I may not be that risk averse about that. I might be able to smooth kind of over days. So that's another reason it might be different. Other questions? Comments? Yeah, sure. Sorry, you're going to have to speak up. I can't really.
In the setup, when the founders are risk averse, it's first best to share risk. Right? Like, even if the effort was perfectly.
Yeah. Sorry. So when I say first best, I meant first best in terms of output. But yes, the optimal the socially optimal contract includes sharing risk, but it does not get the first best level of output.
So here, moral hazard doesn't have a first best coincides.
Doesn't what? Sorry.
Does moral hazard have a bind? Like, does the fact that they can't observe effort, does that change the allocation? It seems like it doesn't. Like, first best just coincide with the second best.
No. So no. So what would be if we could observe effort? What would be the first best contract? First best contract would be we'd write a contract based on effort, and we would observe but we'd provide you full insurance. So the first best contract would have, like, if we could contract on effort, we would say you put in E equals big H over C, and I'll pay you H equals L equals the expected value equals W lower bar basically. Yeah, that would be the first best contract. Other questions? Okay. All right. So that's the risk aversion version. So what about the limited liability version? Okay. So let's go back now to risk neutrality for a second. Okay. But let's impose limited liability. So let's assume that we can't impose L less than 0. Okay. So now what happens to the optimal contract? Well, now the landlord has lost a degree of freedom, right? The landlord before could choose little h and little l. Now they can. Now they have this problem that little h can't, little l can't go below 0. Okay. So so in the first best kind of contract, we had this. What happens? Suppose we're in the world where this thing is. If this thing is positive, then like great, we have no problem, right? But if this thing is negative, right, then we can't write that contract anymore, right? Because in the low state, they just won't pay. Another way of saying it is they won't pay the rent, right? So what do we do? What does the landlord do? Okay. So instead, so little l has to be equal to 0, right? Because it can't be. It's bounded by limited liability. So what happens to h? So now, right, we know the optimal choice of effort. So the landlord is going to say, well, I'm just going to choose. All I'm ever going to get if the landlord is a payment in the high state. I'm never going to get any money in the low state. Okay. So but I know still the agent is only going to be incentivized based on the difference between the little h and little l. So now I'm stuck solving this contract, which is, I'm going to maximize my return, which is the probability of the high state, times what I get paid in the high state. And the low state is just kind of a wash, right? I don't get anything in the low state. So that's this problem over here. This is h over c, right? We know that the tenant is going to choose h minus l over c, but there's l is equal to 0, so the tenant is going to choose little h over c times big H over c, and so the optimal choice here for the effort is just for the landlord is to choose little h equal to big H over 2, and therefore the optimal amount of effort is going to be big H over 2c. Okay, everyone see that? All right. So okay, so again, we have less than the first best amount of effort, right? First best amount of effort was big H over c. Now we only have big H over 2c, so we have half of the optimal amount of effort, right? So we're also in a world here where, so that's the point number 1. And point number 2, this is a sharecropping contract, right? Because in the high state, you keep half, the landlord gets half, tenant gets half. In the low state, nobody gets anything. So this looks like a perfect share contract. In this simple example, it's a share contract with a share equal to a half. Okay? So now, what happens if we have an IR constraint here? Well, so what's the farmer's utility under this contract? Well, we can solve the farmer's utility under the contract. Farmer's utility under the contract is their choice of effort. We can just solve their choice of effort is going to be little h over c times, and they're going to get to keep payment h in this state, plus they have a cost of effort. So if you solve this out, it's 1/8 big H squared over c, whatever. You can solve that out. The key point, though, is the following, which is that's the landlord's utility. That's the tenant's utility under this. If the tenant is getting at least W lower bar than under this with utility, great, we're done. Fine. Okay. Now, in this case, the tenant also is getting rents. If this thing is exactly equal to W lower bar, fine. But that's kind of like a knife edge case. Like generically, like you may have parameter values where you have to pay the tenant above her outside option in order to get her to work the optimal amount. Right? And what's different here, the difference is like in the other thing, you could just sort of like slide the whole contract up and down kind of arbitrarily so that the expected value was equal to W lower bar, but now you can't because you sort of have this limited liability constraint from below. right? So she may get rents here. And also, the contract doesn't depend on W lower bar anymore in this piece of it, right? As long as it kind of as long as the thing is well above W lower bar, move the lower bar up and down, like the contract doesn't change. Whereas in the more hazard one, like it was always kind of moving around so that she got W lower bar in expectation. Now, on the other hand, if this thing is less than W lower bar, now the tenant has to actually, the landlord has to increase kind of the share that the tenant gets to keep in the high state, so that she gets at least her outside option expectation. Okay, so what will happen in that case? We'll just pick H such that sort of the expectation in the high state is just exactly equal to the expected value of the contract is exactly equal to the outside wage. And note that in this case, increasing W lower bar actually increases effort, because the contract becomes, as her outside option gets better, the contract becomes more attractive. Okay? Clear? Okay. So both kind of key point here is both moral hazard kind of insurance rationales and limited liability rationales both generate what look like sharecropping contracts, but they're very different kind of like stories for what's going on, and they have different implications. Okay, and in particular, so both of these models generate the fact that sort of sharecropping emerges, effort is less than the first best, right? But one thing that's really in particular kind of interesting here is they differ in their implications for land reform. So so as an aside, I feel, and I'll talk about this in like the next slide, I feel like land reform is like in my opinion, like hugely kind of understudied topic. It was like, I feel like, one of the salient issues of the 20th century was sort of like, should we do land reform? I mean, in some sense that you can think of like the whole kind of like, you could think of the whole kind of communist revolutions were really about this question of like, should we do land reform or not? I mean, there were many other things too, but like, should we sort of take away land from the landlords and give it to the farmers? It was like a huge question kind of in the world in the 20th century. And I feel like we don't have I think like the level of evidence we have is not commensurate with kind of the importance of the question, in my view. But in any case, these models differ a lot in terms of the implications of land reform. So what do I mean by that? So in risk aversion, in the risk aversion model, we do a land reform. We say, okay, now tenant, you're the owner of this land, right? That does make you wealthier and makes you maybe less risk averse. But on the other hand, your risk is all kind of tied up in your wealth is all tied up in the land. So it's not easy. That's not clear. You can sort of get consumption smoothing benefits from that. Maybe you can if you can borrow. Maybe you can't. But you're still kind of would want some insurance, right? And so you might, as a tenant, say, well, I don't want to be in this position of, being the owner and bearing all this risk. I might prefer actually to be in a contract where I'm sharing some of the benefits and some of the costs, or sharing some of the returns in return for some kind of insurance. So you could imagine in a risk aversion model that some kind of these sharecropping arrangements might kind of re-emerge endogenously, right? You could imagine, for example, a landlord might make you an offer and say, I'll buy the land from you, right? And then I'll provide you a share contract, and that might be better, for, including the payment they get upfront for the sort of value of the land. They might be better off for that because then they're getting some insurance value sort of later. And there's a trade-off there, but because insurance is kind of helpful, it might emerge endogenously. Under limited liability, no. Right? Under a limited liability model, like the only reason we had the sharecropping was we couldn't make this payment from the tenant to the landlord in the low state. But if I'm the owner, like I'm good. Like I don't have to pay anybody. So like, and I'm not risk averse in that model. It was a risk neutral model. So which of these models is important would have implications for sort of what you would do in the context of a land reform. Okay. Comments? Questions? Yeah, Kailash.
Do we know about that question whether it's good to give the land back to the
I'm going to talk about that in a few minutes. I'm not going to talk about much, but I'm going to talk about a little bit. There are a couple papers I'm waiting for. I'm still waiting for the Great Land Reform paper. There are some there's some really nice papers that I'll talk about, but I feel like there are various challenges. I'll talk about a few of them in a couple slides. Yeah, Reka.
If both effects are present at the same time, does this just default to the limited liability case?
I'm sorry, I didn't understand.
If both effects are present at the same time.
No, I think you would do some. Hold on, let me think. Yeah, it's got to, right? Because if you're capped at the whole limited liability thing, if you add risk aversion to the limited liability thing, yeah, you're still gonna have a problem. You can't pay the rent in the low state. So yeah, I think if the thing is binding, then that sort of limits your ability to sort of trade off kind of a fixed fee for insurance value. So yes, I think so. Other questions? Okay. All right. So now that kind of brings us to the paper you guys read for today, which is. Do we actually think that so one implication of these models is that that there is kind of some that sort of the incentive that the contract is going to affect kind of the effort choice, right? And you don't actually need the full. That's true under any of these models, right? That we talked about. You can go back to the very simple one, the two-line one I put up in the very beginning. But that's kind of a key kind of parameter that we need to sort of understand all this. So, so before you actually got to an experiment, before we had an experiment, if you didn't have an experiment, like when we talked about, how would you go about estimating this thing? What would you want to estimate this? What kind of regression would you want to run? Somebody. Yeah, Paolo.
You maybe want something that's output based on what share of outputs that they have between the entity side. Cancel out individual farmers.
What's that?
Or so you'd want a regression where your output variable is the output of the farm, and you want as an input of one of your regressors, what share of output or profits they're getting, essentially the terms of the contract.
Sorry, I'm sorry, I don't fully understand. So say it again. So you yes, you want to put output on the left-hand side, right? What do you want to put on the right-hand side?
Basically, terms of the contract.
Right, exactly. Right. The same thing you do. You'd like to regress what is the output on what are the terms of the contract, right? But the problem is, of course, that those farmers may be different. Okay, so one thing to do actually would be if you had multiple farmers. So if you had farmers who had multiple plots. So the basic problem with that regression is we have there might be farmer characteristics that might be different, right? Farmers who enter into those different contracts might be different people. So one option would be to use farmers who have multiple plots, some share cropped and some owned, right? And run this regression with farmer fixed effects, and say, are they putting in more effort on the owned plots compared to the shared plots, for example, or more inputs or whatever. Okay, so would that be a good regression or a bad regression? So that regression would basically, sorry, yeah, Reka. Go ahead, you can answer the question.
Could there be an issue with some qualities of the land that cause it to be?
Absolutely, yes, right. So there could be a problem with quality of the land, right? So it may be that different land is owned versus rented, and therefore that could be related to the issue. And okay, so in fact, so the regression you could run is some output as a function of sort of whether it's owned or not with farmer fixed effects. And this could be either inputs or outputs. Okay. So the problem is exactly this one that you mentioned of sort of quality. So this is from an older paper. And you can basically see that they have looking among the owned plot, this doesn't have the fixed effects, but I think the same thing goes through the fixed effects. If you compare the owned plots, the sharecrop plots, and the fixed rent plots, the owned plots look a lot better in terms of their, say, average value than the sharecropped plots. Actually, in this case, the fixed rent ones, I think, look kind of the worst of all, at least in some of the villages. So the point, though, is that you may have different, and by the way, if this is too small to read, that's why you have the handout. So if, so that's why this regression may be sort of challenging, okay? And so, the original approaches before we had this RCT and the paper that we used to teach here was to say, let's control for kind of really detailed plot characteristics, okay? And the problem is that the problem here is that there may be sort of unobservable characteristics of the plot beyond the measurable plot characteristics. It's really hard to if you end up writing an agriculture paper, you'll go into the weeds, so to speak, and you will find like an incredible amount of like how you describe a plot characteristics and soil quality and water quality and this, that, and the other thing is like many, many, many dimensional, and so that approach is really hard to sort of get that right. Okay, so what would be cool is would be to have plot fixed effects, right, in this regression. Like maybe some plots change, but then of course the question is why they're changing, right? So all of this basically, actually I can't find a paper that does that because probably the contracts don't change, and maybe we don't know why they don't change. So that all leads us to the paper you guys read for today, which is, I think, why this paper, even though, as some of you guys noted, the setting is a little unusual, right? It's these kind of, new farmers who are kind of interested in farming as part of these kind of women's groups, and sort of it's not that sort of the external validity of this may not necessarily be 100% there. The reason I think this paper is got so much attention is it is kind of the cleanest paper that we know of that actually sort of like tests this. So as you guys saw, right, what are they going to do? They're going to work with tenant farmers in Uganda, randomize them to receive either 50% of their output. So after they recruit them, right? So it's going to be surprise randomization. So there's no selection issues, right? Have either 50. So the baseline is 50% of output. Or you can get to keep 75% of your output, or 50% of your output plus an exogenous cash transfer calibrated to be equal to 25% of output and expectation, either as a fixed fee or a risky contract. Okay, so that's the basic design. Okay, so what did you guys? I'm curious to know. What did you guys think of this? You like this? You like this paper? You have concerns about it? Like, what did you think? Yeah, Aaron.
So one concern I had was with how they're trying to test for the fact that like these incentive effects do explain what they observe, not income or risk effects. And so they kind of argue that their risky exogenous cash transfer is a way of making sure that these risk effects don't exist. But what I thought was funny was they draw really heavily on this like the Marshall's kind of model, but that. In that model, what you see is that the probability of having like a high output is dependent on your inputs, whereas in theirs, for the risky exogenous case, it does not. It's whether or not you get that additional 25% in the risky case.
It's exogenous, right?
Yeah, it doesn't depend on your inputs. Versus in the 75% of output, that extra 25% most certainly does. And so I thought that.
So what's the concern there?
Well, so given that if this additional 25% depends on your inputs are going to change, versus if it does not. And so I think I don't understand how then you can say that risk does not account for what you see.
Okay, so does anyone else have anyone want to respond to that? Does anyone comment? Any idea? Any thoughts? So, no? Yeah?
I'm thinking of the fixed, like the 50% plus an exogenous cash transfer where they get the fixed amount. That does insure you completely, no?
That is a what?
Insure you completely. Like that's a safe insurance, so it is 25% because you can still.
Yeah, but right. So the point of this one is not about insurance. The point of this is an income effects. Right. So the point of this one is to say, well, maybe they're like doing more stuff because they're richer, in expectation. Like maybe they somehow maybe they're, I don't know, not quite credit constrained, but maybe they're sort of credit constrained. You know, maybe they only feel like they can afford to buy fertilizer if they're going to get a higher payment at the end. So that's what this one is for. Is the level, right? Well, I think Aaron's concern, if I understand it correctly, Aaron, correct me if I'm wrong, was that the issue with this one is that the payment here doesn't depend on your inputs, and so it doesn't exactly mirror the riskiness you would have in this contract because you would, because here you would also be putting in more inputs and therefore your net returns would be different. Is that your point? Yeah. So I think at least the way I think about this is to say, this is actually testing a different issue, which is to say, look, let's suppose that there's two thoughts. The first is to say, to first order, this contract, gives you a lot, so plus and minuses. Yeah, I think what they're trying to say is, yes, this contract is just generally more risky than the other one, and so if you thought that like what was happening is I was changing my behavior because I'm exposed to more risk in some general sense, you would see things that look more similar between this and this. So I agree with you that it is different. It's not exactly the same in a couple respects. The first is this risky contract is actually not as risky as this risky contract, because this one, I think, if I remember correctly, is exogenous risk, whereas this one is and sort of like independent risk, whereas this one is correlated with the rest of your risk, right? So actually, to me, the first order issue is that one, which is sort of like this one is, and I don't think this one, someone correct me if I'm wrong, this is just an exogenous risky payment, right? Yeah, like a random draw random thing, right? So one thing that might have been even slightly better to deal with, this is not your issue, but deal with this other issue, might have been to say, well, I'm going to tie the risky contract to, say, average returns in the neighborhood, like in your area. So at least it becomes a correlated shock, not an independent shock, because otherwise this is like, this risk, it's like less risky than this because like it's independent. You see what I'm saying? It's not a correlated shock. To your point, I don't know of a good way. I see your point that sort of the net risk. Your point is if I write down the utility sort of under the things that the net risk is the same because I haven't put in these additional inputs. I don't know of a good way to deal with that though. Do you? What are some other what other concerns did you guys have about this paper? I know in general, actually, I haven't read all your comments. You all pretty much liked it, but were there other concerns that you guys had looking over it? Or things you would have wanted them to do differently? Yeah, Paolo.
I think that one of the things that I was thinking about is in making this experiment ex ante and what the outcome that you're going to get is either something along the lines of, okay, it's mainly income effects, or it's mainly these incentive and moral hazard effects, or some combination of the two, or neither of them. And so I think for me, just in terms of policy applications, is what is one supposed to get from this paper? Had it been income effects, I think there's a very clear answer of just give these tenants money and then you can be more productive. But given that the answer was this mainly a moral hazard.
There's moral hazard.
Yeah. So what is going to be the reform that a government or something does as a result? It seems very hard to just tell everyone to change the terms of contracts if you're tenants or things like that.
That's a good question. What other comments on that? Did anyone else? Is there sort of an obvious policy implication in this? Yeah.
One thing that I was thinking about was instead of just saying oh, I'm going to take 50% of your output or only 25% of your output, if you could have some sort of staggered design in your contract where you would say I'll initially take 50%, but like if you make above this amount in your output, I'm gonna take less. So then you have an incentive to keep producing more as you go along. And I would be curious what that would actually look like implemented, and if that would.
Yeah. So this gets back to this whole question of like, are linear contracts optimal? So I'm gonna not go into that in a lot of detail and refer you to a contract theory class for this question. But I think there's a couple of issues. The first is, I think the general issue with nonlinear contracts is you want to sort of put the part where you give people the most incentive at kind of the point where they're sort of most elastic, and figuring that out with heterogeneity across people can be tricky. So it might be. And if I put it in the wrong place, then I can so you sort of want to say I want to so that can be kind of a tricky set of issues. And the other thing is you can also get kind of gaming if you can do things across periods. You can sometimes get gaming. I don't know if that's really an issue in sharecropping contracts. And actually, I don't know of a good. I'm sure there is a paper. I just can't think of it off the top of my head that has taken some of the Holmstrom linear contracts ideas and sort of said, do these kind of gaming or other sort of issues apply to kind of this sharecropping context? I don't know the answer to that question. Yeah, Wesley.
My only thought on the policy implication of things is that what seems a little bit strange about this particular setting, vis-a-vis like how sharecropping contracts actually work in practice, is that BRAC does not care if it's maximizing its profits and it's getting as much out of these sharecroppers as it possibly can. And so even if the result is that if you were to increase the portion of the output that your sharecroppies can keep, there's not really a way to impose that on landlords who are looking to extract as much as they can out of the contract, unless, similar to what you were saying, if there was some income effect where or if your landlord is a government who doesn't particularly care about taking a little bit of a loss and is just looking to increase the output on the land.
Yeah, so I mean, I think, my own take on this is I don't necessarily think there's an obvious policy implication of this paper because it doesn't actually tell us if it's the insurance issue. It doesn't tell us it tells us there's some inefficiency going on in terms of it says that there's some inefficiency going on where sort of the sharecropping is reducing effort, but it doesn't address the questions we talked about before of why is this emerging endogenously, and it seems like we need to know that in order to figure out the policy answer. So I think to me this is an important piece of the puzzle. It says first point is yes, these contracts have efficiency consequences. So that's actually really important because if they didn't have efficiency consequences, we would just not worry about this whole set of issues from an aggregate welfare perspective, aggregate productivity perspective. The fact that it does say that there's efficiency consequences says to me that, well, okay, now we want to figure out what's driving it. And if you really thought that the issue was about insurance value, is there a way of providing insurance that doesn't have the same moral hazard consequences? And there is a small but kind of growing literature on agricultural insurance issues, and I'll tell you actually the main challenge with agricultural insurance is I don't want to write, because of these moral hazard issues, I can't insure your output, otherwise you don't work. So what I do is I write insurance based on your predicted output, which is essentially I write insurance based on the weather, for example. So actually you can buy, in the US or in other places, you can buy weather insurance essentially. So if it's a drought, you can buy insurance against a drought. That's an exogenous event that's going to reduce your output. So we can insure you to some degree that way. The problem with those insurance contracts is the thing we're insuring is not perfectly correlated with your shock, and so they don't provide kind of as good insurance as you might like. And that issue is what's called basis risk, that sort of the thing we're insuring is not perfectly correlated with your shocks. And so if you're interested in that, there are some papers that sort of have tried to think about that. But if you thought that sort of the issue was kind of risk aversion, then you would be kind of heading in this insurance direction. And if you thought the issue was limited liability, then you might head in a different direction of kind of can we basically make some transfers to people so that they kind of don't have this limited liability constraint? Or can we help them facilitate them writing? We might be if we thought limited liability was an issue, we might be much more interested in writing long-term things that look more like debt contracts, for example, and facilitating that sort of thing, which we might not be interested in if other things are important. Yeah. Oh, Reka, go ahead.
I was wondering, is there a benefit to if you wanted to do some sort of staggered levels of incentives from like getting a panel, if that was possible, as opposed to like a sequence of
repeated cross
sections. If you're trying to like back out what like certain types of workers might be and like how those elasticities might differ between groups, or from the perspective of for policy implications, does that not end up mattering?
So I don't think. So you're saying if we had panel and we sort of like get like repeated observations of so.
You changing your contract.
Yeah. So I think it would be yes. So I think if you basically found that everybody was the same, right? If there was no heterogeneity in people's responsiveness at different points in the contract, then you might be more willing to do some of those like nonlinear funky contracts. So yes, in that sense, yes. But like my strong suspicion, you do that, you'd find heterogeneity because there's heterogeneity in most things in life, and then so I'm not sure as a practical matter it would make a huge difference. Yeah, for sure.
Is the right way to think about this paper that in the framework of the model we just looked at, that this is basically estimating the IC constraint or like the agents problem, and so, but then like what is optimal would depend on like a bunch of other things, right?
Yep. Yes, I like that. It's exactly sort of saying we're randomly varying the contract and looking at how the agent responds.
And it's just telling us that the fact that the agent responds, like the IC constraint is somewhat meaningful.
Is what?
Like it's telling us that
it's important.
It's important. Okay.
Yes. Other comments? Yeah, right.
You knew there existed heterogeneity, but then the person who's giving the contract could just like administer some tests to you by varying your contract at the start of your like sharecropping relationship, so they can elicit your type.
Yeah.
And could you have like complicated contracts?
Well, yes, except you would need to like find incentive compatible ways of getting that information.
Yeah.
So, I'm playing a game with my landlord, and I know that the answers to my game are going to affect my contract, may affect how I play the game, right? So, but I do. I think you're onto something. This question is sort of like, can we find incentive compatible mechanisms for getting like better contracts? I don't know the answer to that, but maybe yes. I don't know the answer.
I would imagine if it was like long term enough, years, then I don't know. Maybe people don't vote.
Yeah. So let me. Like I keep sort of referring you to contract theory classes. Like, no, in all seriousness, like, these questions are sort of like, how do I design contracts and how do I get you to reveal information that are going to be, how do I design an incentive compatible mechanism that's going to have you reveal information that's going to let me give you a better contract? That sort of thinking about these things, these models in more. If you're interested in these models in more detail, like that's where we explore them. And I'm not a contract theorist, although I did take that class many years ago. So I apologize for not having like all of the answers off the top of my head, but I have some of them. Okay. All right. Okay. A few other things I wanted to say about this paper. Okay. First point is. So this is the 75% contract versus the 50% contract, okay? And nothing else really makes a big difference. So also going back to, I think, Aaron, your comment of like, is the risky thing like, it may not be exactly the same, but it's certainly not the case that like this contract these results look anything like those results, right? So plus also you actually might imagine it would go the other way. Like this, like, I'm making kind of the world, I'm making myself more risky. That you might actually think, if anything, this could go the opposite direction. It actually might make me kind of more conservative in some sense. But anyway, it's certainly like to your point. Like I agree with you. You're right, but I think also it's a little bit not necessarily like it may not be perfectly right, but to first order, it's not like I look at this and I say, oh, it doesn't look like it's really the riskiness. It's kind of like resulting in these effects. They're just like so different. Several of you picked up in your response notes this question of randomization inference. Okay, so how many of you have seen randomization inference before? Yes? All of you? Great. What, sorry? Great. so I won't go into that in any more detail. Great, awesome. Okay. You see some effects on the intensive margin of capital usage of various inputs. Okay, so it does look like some input. So I do use more inputs. You also see some impacts on unpaid labor, like family labor. Some of you had questions of kind of what this is. Like, I think the idea is like we have lots of people in the household who also are kind of working on the farm, and I'm going to talk a lot about unpaid versus paid labor in the labor section. So let me not answer the questions of kind of what do we mean about paid and unpaid labor now, but like let me defer that to there's a paper by Dan Benjamin that I'm going to talk about in like a lot of detail in like the first labor lecture, which is going to like think about this issue like why is there a difference actually between why might this respond and this not respond? There's like an enormous literature on that question, and I'm going to talk about that. I'm just going to push that over to the land lecture. Okay, but we do see that, and the third thing we see is that we see a change in the kind of crop. So we see like maize goes up and tomatoes go up, and I guess peanuts I think can go up in some of the specifications. And they argue that sort of beans are kind of a safer crop in this context. The other ones are more risky crops, and so I take kind of these more high risk, high return kind of crops, which is not obvious. But one thing I just wanted to point out was that the moral hazard model had this unobservable or at least non-contractable effort thing going on. And I wanted to ask what you thought in terms of, if you think about the results, like is the thing that's changing kind of contractible or non-contractible? Like you're sort of trying to map the sort of results to the theory. What do you think? Yeah, it's not bad.
Well, I think that type of crop is contractable. Like what?
Seems like it, right? Like seems like type of crop is pretty darn observable. Right? Like, are you planting like corn? Or are you planting peanuts? Or are you planting beans? Like it's like pretty easy to sort of like figure out. Yeah. How about some of the other stuff?
Maybe the amount of fertilizer is also.
Yeah, maybe those are harder. So to me, in some sense, one of the things that I think is a little surprising here is that like at least, and they sort of do this decomposition thing, right? And they sort of about half of it is sorry, what's observable, what's not observable. Let me not answer that. But they sort of say what are the obvious sort of the inputs of the production function, like land, labor, capital is about half, and crop choice is kind of the other half. To me, actually, crop choice seems kind of the most observable and contractible of all of this. So in some sense, that's a bit of a puzzle, actually, right? Like, why can't we solve some of these problems by sort of contracting on crop choice? From the perspective of the model, I think is sort of a interesting question. Other comments? Any other comments on that paper before I kind of move on? Yeah, Davey. What's that?
This cost is to observe it, so all of this can be observed in some way, but just the cost of it.
Well, I don't know. Like these sharecropping contracts, sometimes they're literally paid in kind. Like literally, like certainly I've seen examples where like you literally deliver like X bushels of rice, and then it's pretty observable kind of what the crop was. I think in general we want to monitor what the output is in order to figure out the half. So like I think that they got pretty much know. Yeah, Kailash.
Do you think it would have been nice to measure risk preferences just directly in training?
I think that would have been interesting. In some sense, the paper, although going to the previous point, the paper is really about kind of the responsiveness to the contract. It's about the IC constraint, which doesn't really depend on your risk preferences as much. Right? So if this was a paper about ex ante, what would be the optimal contract, then for sure that seems really important. It's not obvious. It's not as obvious to me how important that is, given this is kind of about how the agent is responding. You see what I'm saying? Yeah.
Agent is risk averse. Like, what if you're trying to? That would be important for the IC, right?
The agent, why?
like the agent is the farmer.
Yeah.
So
I mean, it's relevant vis-a-vis. I mean, they're doing it sort of the other way around by sort of making the contract these objects more risky. But that, so you're right. Yes, this contract does change the amount of risk they're exposed to, but so I do. I mean, it is kind of relevant, but if we think back to kind of why did we care about risk aversion so much in all the models we went through today, it was more vis-a-vis the ex-ante contract choice, not about the sort of the IC constraint. And I liked whoever sort of framed this as sort of saying this is a paper about the IC constraint, and sort of I think that's right. And the risk aversion, yes, I mean it does sort of matter there, but much less. Okay, other questions? We're basically out of time. Okay, so we'll stop here, and I'll pick up on Monday with the second half of this stuff, which is all going to be talking about, primarily going to talk about land tenure, and I'll talk a little bit about some of the land reform papers, just very briefly, and then I'm mostly going to talk about sort of security of property rights and investment decisions and things like that. Okay, I'll see you all on Monday.